So we are going to look at the different exponent rules, trying to see what you guys remember. This was taught in Math 1 and Math 2, so this should hopefully be a refresher. We're going to go over everything on here up through fractional exponents was properties that were taught in Math 1. That is the only one down here at the bottom that was taught in Math 2. First up, you've got your product rule. So you've got things that have the same base and have a different power. So we have two same bases, they have different powers. What we are going to do to combine those together, we are going to add the powers. So if we have the exact same base, we are going to add the powers. So if we have a simple example, we have x to the 4th times x to the 6th. This could be fully written out as you have 4 x's and you have 6 x's. So you have 4 x's times 6 x's. It gives you a total of 10 x's, because we have x to the 4 plus 6 equals x to the 10th. A more complicated version of it, if we have coefficients, you still multiply those like you would normally. You're going to do 2 times 4, and then you'll do what you have with your variables. I have my x squareds, I have my y's. I have 3 of them, and then I have 9 more. Then I have z to the 4th. Now we can combine all this stuff together. I have 2 times 4 gives me 8. I only have one set of x's. My y's combined to give me 12. I had 3, I added 9 more. Then I have z to the 4th. That's my product rule. Quotient rule is kind of the opposite of that. If we have the same base, but we have different exponents and they're being divided, we are going to subtract the powers. We can kind of picture this as canceling out. We've got 6 of these x's on the top and 4 on the bottom. So it's like for each one that you have on the top, you can cancel out one on the bottom. So to do this, we're going to have x to the 6 minus 4. So I'm going to cancel out 4 of those x's. It's going to leave me with 2 x's. The bigger number is where your answer goes. So if I had the 6 on the bottom instead, I would end up with my number on the bottom of the fraction, because I'm going to end up with more x's on the bottom than I am on the top. So let's look at a more complicated example. We're going to do coefficients, which is just the big numbers out front, separately. That's going to be 3 over 9. Let's do the a's. I have a 4 on top, 2 on the bottom. And for b's, I have 9 on the top, 7 on the bottom. So 3 over 9. I can simplify that fraction by dividing both of these by 3. It's going to leave me a 1 on top, 3 on the bottom. For my a's, I'm going to have 4 minus 2, leaves me 2 on top. B's, I have 9 minus 7, it's going to leave me 2 on top. I basically canceled out a whole bunch of them. Next up, we got power rule. This one here, it's gonna seem like it's similar to product rule. This is where you're gonna get confused. But with the power rule, we are going to have just one base and 2 different exponents. We are going to add, or sorry, not add, we are going to multiply. I did it too. We're going to multiply the exponents. So I'm going to write this out. We have x to the fifth and we're squaring it. So anytime we square something, we have two of them. So we have x to the fifth times x to the fifth. Now it looks like what we had up here. If you write it out, it looks like your product rule. So if we would now be able to add those exponents together, because we don't have x to the 5 plus x to the 2. We have two groups of x to the 5. That's how we end up with x to the 10. Here we are going to have three groups of y to the 8. So we are going to have y to the 8 times 3 or y to the 24. Power rule is groupings. Product of a power rule, this is basically fancy distribution. Your key thing here is to make sure you distribute your power to every single thing you have. So if I have an A on the outside, it goes to every single thing I have on the inside of my parentheses. So if they have no powers to begin with, I'm just going to be plopping a power on there. X to the 5, y to the 5. Because they have an imaginary 1 on there. And 1 times 5 is 5. 1 times 5 is 5. With things that already have powers, it gets a little more complicated. We have negative 3 squared, x squared, squared, and y to the 4th squared. We can simplify all of these. Negative 3 squared is negative 3 times itself. So negative 3 times negative 3 is going to be 9. X squared is two groups of x squared. So we're going to use the power rule once we break it down. We've got a times b, so 2 times 2. Two groups of 2 is 4. Same with y's. I have two groups of 4. Gives me y to the 8th. We can use that same principle for the power of a quotient rule. This a, whatever number we have on the outside, gets distributed to everything we have on the inside here. So it goes to the thing on the top and the thing on the bottom. So if you don't have any exponents to begin with, we are just putting an exponent on there. Because we had x to the 1 times 4, y to the 1 times 4. Gives us x to the 4th over y to the 4th. Now, we're going to do this one here. We're going to put this squared on every single thing we have here. So I'm going to have 4 squared, x to the 4th squared, 3 squared, and then an x squared. 4 squared is going to give me 16. Two groups of x to the 4th is using my power rule again. So I'm going to have x to the 4th times 2 gives me x to the 8th. 3 squared gives me 9. And then I keep the x squared. Now you're not finished here. We need to use the quotient rule and clean this up a little bit. Because like we had up here, we have a's on the top, a's on the bottom. Here we got x's on top and x's on bottom. I cannot simplify 16 over 9. But if I have 8 x's on the top, 2 on the bottom, I can cancel out 2 on the top, 2 on the bottom. So I'm going to be left with x to the 6th. Next one's a little bit easier. Zero exponent rule. Anything to the 0 power equals 1. So the way this works, you're going to see this multiple different ways. Let me change this one quick. That way it's more representative of the examples you're going to see. I wanted to have you give you two different kinds. We're going to distribute using the power of a product rule and put this 2 onto everything we have in our parentheses. So we're going to have 3 squared. M to the 0, anything to the 0 power is 1. So that's just going to give me 1 squared. So 3 squared times 1 squared is just 9. Or if you can't, if you have trouble remembering that, we're going to do it and pretend we don't remember that part. So we're going to do it as 3 squared times m to the 0 times 2. Or 3 squared times m to the 0. We're still going to end up at 9 times m to the 0. And you still need to know m to the 0 equals 1. Gets us to 9. Now, if we've got the 0 on the outside, we distribute a 0 to everything we have. 2 to the 0 times e to the 0. It does not matter what you have. Anything to the 0 power equals 1. So 2 to the 0 equals 1. E to the 0 equals 1. You get a big fat 1 out of this. If the 0 is on the outside of your parentheses as your power, you're going to end up with 1. We're at the last two. Negative exponents. If you have a negative exponent, to get rid of that negative exponent, you are going to move it to the opposite side of a fraction. So if it's on the top, you move it to the bottom. If it's on the bottom, you move it to the top. So if we've got a simple one where we have x to the negative 4, we do not want to have a negative exponent in any of our answers. So we are going to move it to the bottom of a fraction. We're going to make it 1 over x to the 4. And that is the final answer. That's all you have to do to get rid of a negative exponent. Number 2, we're going to try to get rid of the negative exponents before we do anything. So I'm going to keep the 2 and the 3 because I can't do anything about those. If I want to get rid of this x to the negative 1, I move it to the bottom of the fraction because I have to move it to get rid of the negative. If I want to get rid of this x to the negative 2, I move it to the other side of the fraction. Now I'm way back up at using this quotient rule. So I have negative 2 thirds. I have 2 x's on top, 1 on the bottom. I'm going to end up with just 1 x and it's going to be on the top. So your answer could look like that, or negative 2x over 3. These are the exact same thing. Either one will work. The last one is the only one that's probably going to be a little bit more confusing. This is the fractional exponents. So the ones that you probably saw first were like x to the 1/2 or anything to the 1/2. This would be a square root. So if you have x to the a over b, you are going to be able to rewrite it as your x goes on the outside, b goes here, and a goes here. So this is the bth root of x to the a power. We're going to use this but we're going to be simplifying these is the main thing. So we're going to rewrite this first using this exponent rule. So I'm going to rewrite this here as x to the 3 goes out here, 5 goes in here. Because I have x to the 5th, but I have the third root of x to the 5th. Now, I need to simplify this. It's simplifying radicals at this point. So I need to see how to rewrite this into how many things I can take out of this third root. So how many multiples of x to the third can come out? Because x, the cube root of x to the third would be x. Just like the square root of x squared equals x. We're simplifying, so we're going to break it down. Using that product, we're doing like the opposite of our product rule. We can take this 5 and split it into 3 plus 2. So if I have x to the 3 times x squared, I can combine those back together to get x to the 5th. But I want to split them apart into x to the cubed, x third times x squared. Now, if I separate this into the two pieces, this first part here becomes just a plain x, because the third root of x to the third is just x. But I'm stuck with this other part here. I do not have enough x's to take it out of that root yet. I have to leave it as is. We're going to do the same with this one here. So we're going to do our multiplying first. So I get 4. I got to use my product rule. I multiply my coefficients. I have a 4 times a 1 gives me 4. I add my powers together. I have x, and I have 3 plus 1/2. So that's going to give me 7 halves. Now I'm going to rewrite this as I have x to the 7th, and I'm taking the second, or I'm taking the square root of that. Now, how many sets of 2 are in 7? That's what we got to figure out next. There are 3 sets of 2. So 3 sets of 2 would give me 6. So I can split it into x to the 6 times x. And from there, you can get your final answer of 4. I can take half, which is the square root, half of x to the 6th is x to the 3rd, because what I'm doing is x to the 6th times 1/2, or using our power rule, x to the 6th times 1/2 gives me x to the 3rd. It's going to give me my fractional exponent. This is going to be the one you're going to see the least. You may not even see this on your EOC. So I don't want you to stress about the one on the bottom. The ones you are going to see is all of the ones up above. The main thing is knowing how to combine the fractional exponents together, knowing really before, because your final answers can look something like this: 4x to the 7/2 for Math 3. And that would probably be perfectly fine. I'm not going to expect you to probably fully go this way. I'm going to double check with the other math teachers, but you probably don't need to do all this.